Welcome back. Now that you understand the core concepts of Model Context Protocol, it's time to bring them to life. In this chapter, we're exploring practical implementation of Model Context Protocol, what it takes to build, test, and deploy MCP applications across real-world scenarios. So whether you're an enterprise developer integrating AI into workflows, or a solo builder prototyping your own intelligent assistant, this is where things get even more hands-on. The real power of MCP isn't just in understanding how it works, it's in applying it. This chapter bridges the gap between theory and practice, giving you the tools to implement MCP across multiple programming languages, using official SDKs built for C#, Java, TypeScript, JavaScript, and Python. Each SDK provides the building blocks you need. There's simple MCP clients, full-featured servers, and support for key MCP features like tools, prompts, and resources. You'll find example projects and starter templates in the MCP samples directory, so you don't have to start from scratch. So let's talk about what you're actually building. At the heart of every MCP implementation is the server. And the server is equipped with three core features: resources, prompts, and tools. Resources provide context, like documents, structured data, or files. Prompts shape the interaction, guiding the model through templates or workflows. And tools let the model take action, calling functions, hitting APIs, or performing calculations. Think of it like this. Resources are what the model knows, prompts are how it's asked, and tools are what it can do. The MCP SDK repositories come with sample implementations in your favorite language. In C#, you'll see basic and advanced server setups, including ASP.NET integrations and tool patterns. In Java, you get Spring-ready builds with reactive programming and type-safe error handling. The JavaScript SDK supports both Node and the browser, with WebSocket streaming built in. As for Python, it's async native with fast API or Flask support and integrates naturally with ML tools. So once you got your server running, what's next? Testing and debugging. MCP Inspector is your go-to tool for inspecting live server behavior. After deploying your server, just connect via your API endpoint, list the available tools, and run them in real time. It's like a live console for your agent. Ready to go live? MCP servers can be deployed to Azure using Azure Functions. Even better, you can add Azure API management in front of your MCP server to handle rate limits and token auth, monitor performance, balance load, and secure your endpoints with OAuth via Microsoft Entra. With just a few commands using AZDup, you can deploy everything: function apps, API management, and all dependencies automatically. And if you're wondering, can I test this locally before I ship it? Absolutely. These examples are designed to work both locally and in the cloud, so you can iterate fast and scale later. The remote MCP function samples show how to implement secure, production-ready servers in C#, Python, or TypeScript, complete with network isolation, OAuth, and support for GitHub Copilot agent mode. Before we wrap up, here are a few key takeaways. Official SDKs make it easy to build MCP apps in your language of choice. Tools, prompts, and resources are the building blocks of any MCP server. MCP Inspector and Azure API Management help you test and secure your deployments. Azure Functions let you scale your solution with just a few CLI commands. And designing good workflows, well, that's where your creativity comes in. Now it's your turn. For the exercise in this chapter, you'll sketch out your own workflow, choose the tools that you'll need, and implement one using the SDK of your choice. In the next chapter, we're going to explore more advanced topics in Model Context Protocol implementation. I'll see you there.